We're given f of x equals x cubed minus 2 divided by x. For part A, we're asked to determine the value of f inverse of 7 without finding f inverse of x. And then for part B, we're asked to determine the value of the derivative of f inverse at x equals 7. So for part A, assuming f of x has an inverse, we'll use the fact that if f of A equals b, then f inverse of b equals a. Another way to think of this is, if the function f contains the point a comma b, then we know the inverse of f must contain the point b comma a. Which means if we can find an x value where f of x equals 7, we can determine the value of f inverse of 7. Let's work on this by making a table of values. We'll let the first column be equal to x, and the second column be equal to f of x. So notice how if we let x equal 1, f of 1 would be equal to 1 cubed minus 2 divided by 1, which would be 1 minus 2, which equals negative 1. So because f of 1 equals negative 1, we know that f inverse of negative 1 must equal 1. But our goal is to find f inverse of 7, not f inverse of negative 1. So we're looking for an x value where x cubed minus 2 divided by x would be equal to 7. Let's try x equals 2. And let's show some work on this one. F of 2 would be equal to 2 cubed minus 2 divided by 2, which would be 8 minus 1, which does equal 7. So now we know f of 2 is equal to 7, and because f of 2 equals 7, we also know f inverse of 7 equals 2, which is the function value we're trying to find for part A. So for part A, we'll say since f of 2 equals 7, f inverse of 7 equals 2. Now for part B, let's look at our notes below. If f of a equals b, and f of x is differentiable at the point a comma b, and f prime of a doesn't equal 0, then f inverse of b equals a, and f inverse of x is differentiable at the point b comma a, and the derivative of f inverse of x equals b equals 1 over f prime of f inverse of b. And because f inverse of b equals a, we can write this as just 1 over f prime of a. So applying this formula, the derivative of f inverse at x equals 7 is equal to 1 over f prime of f inverse of 7. And again, we already know f inverse of 7 equals 2, so we can write this as 1 over f prime of 2. Before we find this value, though, let's look at this graphically. The graph of the given function f of x is graphed here in red. To graph the inverse function, we can reflect f of x across the line y equals x, graphed here in black. So this purple function is the graph of f inverse of x. In part A, to determine the value of f inverse of 7, we determined that f of 2 is equal to 7, which would give us this point on the original function. And because f of 2 equals 7, we also knew f inverse of 7 must equal 2, which gives us this point on the inverse function. And then for part B, using our formula, we wanted to find the value of the derivative of f inverse at x equals 7, which should be the slope of the tangent line at this point. And our formula tells us the slope of this tangent line is equal to the reciprocal of the slope of the tangent line to f of x at the point 2, 7. So the slope of this green tangent line to f inverse of x and the slope of the green tangent line to f of x have reciprocal slopes. So for our next step, we need to find f prime of x. Let's write f of x as f of x equals x cubed, and let's write this as minus 2 times x to the power of negative 1, which means f prime of x is equal to 3x squared. Here we're going to multiply by negative 1, so it's going to be plus 2 times x to the power of negative 1 minus 1, so x to the negative 2, which we can also write as 3x squared plus 2 divided by x squared. And now we need to evaluate this at x equals 2. So f prime of 2 is equal to 3 times 2 squared plus 2 divided by 2 squared. This is going to be 4 times 3, that's 12, plus this is going to be 2/4 or 1/2. So this gives us 12 and 1/2, or as an improper fraction, this would be 25 halves. So because f prime of 2 equals 25 halves, this would be the slope of the tangent line to the original function at x equals 2, but our goal is to find the slope of the tangent line to the inverse function at x equals 7, which is equal to the reciprocal of this value. So we actually have 1 over 25 halves, which would be equal to 2/25. This is equal to 1 divided by 25 halves, which equals 1 times 2/25. So for part B, the derivative of f inverse at x equals 7 is equal to 2/25. We could also say f inverse prime of 7 equals 2/25. Going back to our graph one last time, we just found the slope of the tangent line to the inverse function at the point 7, 2 is equal to 2/25, which is equal to the reciprocal of the slope of the tangent line to the original function at this point here, where the slope was 25 halves. I hope you found this helpful.